Recursion in mathematics. Means mathematics is always supreme. There is no alternative to mathematics. Mathematics is more than 50% of the science it carries on its own head, and others are in less than. Means it is amazing. Anyway, so in programming concepts, we see recursion. So why we use recursion? Recursion means a function is calling itself, or kind of a mutual recursion, or a secondary recursion, dual recursion. One function call itself, but after some time it start calling another function which call itself, or it calls a third function, or it calls first function again. So that is called mutual recursion. Otherwise, it can call any other function that can call itself, or anyone can call anyone, and it can call starting itself again. So recursion is nothing but function call only, simply. But if it calls itself again and again, so that becomes recursion. When we use recursion in programming concept, so recursion is generally people think that it would the idea of a control statement like looping, a for loop or while loop, so it can remove the recursion, means it can replace the recursion, but it is, I don't think so, means it is. So recursion is a kind of idea which kind of is a dynamic substitution of a control statement. Suppose I have a two-dimensional array I need to print, so I will have a two nested loop, and I can print the 2D array. A function takes 2D array and it prints because it has a nested loop. Now, what about a function is provided for four dimensional 4D array? It cannot print individual because it is made for a two-dimensional controller. So controller statements are nice, but they are fixed. Means their dimensions are fixed. But if we go for it, so this is the replacement from the controller statement to recursion. So if our we can say like if our array is dynamic size, then if I have to iterate over something, and then again children I have to iterate, then again children, that dimension is dynamic. Then we go for a simple answer. Another point that comes in recursion is recursion creates a kind of scoping. Since it is a function, so function will have its own stack. So function arguments to all the local variable, they go to its own stack, but that becomes secondary. Means anyway, that anyone can simulate, emulate, because Python kind of languages where we have context managers. So in for loop also we can have context. So that is not an issue. But main issue is the dynamic, means dynamic behavior. Dynamicism. So that is the behavior we need. So one thing, if I need dynamic number of loops in a program, then we go for recursion. So if I have to print a 4D array, then I'll have only one loop in the function, and then I iterate over the loop and call the function again with the next index. So it will go and it will iterate the next kind of dimension in the array. Then again it will iterate and then it will go to next and next. So doesn't matter how many dimension array we are taking, it will keep doing till all the dimensions are satisfied. One thing. Second thing is, the nice thing about the recursion is that we can fork, like depending upon the situation. Like I have to find a number is a even or odd, then I can check if number is 0, then it is even. If it is not 0, then I can call another function subtracting 1. So if number is 2, then I'll pass and I'll call another function with 1. It checks whatever it returns, okay, then that is the kind of, then I'll call myself. Like if number is 2, it goes to another function, it decrements 1. Okay, sorry, so if number is 2 and there are two functions. One is to check the even number, and 1 is just another function. It checks that it is 0 or not. If not, then it decrements 1 and passes it to another function. It checks it is 0 or not. It decrements 1 and passes it back to them. It calls this function again. So it receives 1 and then it receives 0. If it receives 0, then it is an even number because it comes every second time to the function. Okay. Now, if another guy, if it receives 0, then it returns false, and whatever it returns, that we are checking. So it is not an even number. Means recursion we can have forking anywhere. So that is not possible in the control statement. That whenever we is static, whenever we want, we start forking here and there, and then we'll have another control statement. Then we'll have another, then fork. Then so functions are dynamic in the sense that we can fork whenever we want, and then we can make call another function, and they can recurse or they can call another function. Depends upon the scenario. Like Fibonacci series also, we can have 3 functions, and they can call each other. So please use recursion. So what is the drawback in the recursion is every function, it eats up memory, lot in the sense that stack size goes away. The function's minimum argument size, and then it will return that value, and so this much it stores, and local variable what we use. So if you go for very high level of recursion, then a stack would go away. But I think it's okay, means by the kind of language when everything is going on in heap, and we have big machines now, 8 GB, 16 GB. 64-bit machines where heap size would be very high, not on the RAM side. So I think it's all right. That's why Python is becoming famous. So this is the idea. So nice that if a program is extensible and we think that it would grow things in future, then nice to use recursion, then controller statement, so that try that recursion should be in control